half a day. Tomorrow you're wake up. Alright, what is probability distribution? Distribution of the values of the random variables. Yes. And when we have a probability distribution, this is what we normally have. We have what we call random variables. Are you guys?
Yes, sir.
So is it? Alright. You can do this in half an hour.
What does the class in half an hour?
We can do this in half an hour. We can do all of those classes in half an hour.
Alright. Oh, half an hour.
But you have to work with it.
Yes, sir.
You ready? Alright, so books out, pens out, calculator out. I'm going to do the calculator. You ready? If you don't work with me, like, you can take one and a half hours. Because I want to ensure that you get it, right? Everybody get it. Alright, ready? Alright, ready? So, give an example of a variable. Any variable, an example. Give an example of a variable. Any variable. Remember what we said? Variables are?
Yeah.
A discrete variable. Give an example of a discrete variable. We take on whole number value. Give an example of a discrete variable. Let me give you an example. The number of cars that park the car park on the way. You know what? A discrete variable. Yes. Give me one more. Discrete variable. The number of. Yeah? Actually, that's an example. Alright. Yeah, can I have data?
No.
You have no data? No.
On the Wi-Fi now, you
Give the data now. I did still have an issue. I was having some problems there. Alright. I was going to ask you for more examples, but to understand the concept of because we have to talk about variables before we can talk about random variables, and then probability distribution. Alright. So we have discrete variables, we have continuous variables, right? You know the difference? The continuous are the ones that are measured, that you can measure, like temperature. What else? Height, weight, age is time, so it will be continuous. Yeah? But somebody can be 1 year and 2 months and 2 days. So like 1 point something, right? Okay, so we have discrete variables and continuous variables. When we use them to form probability distribution, we can get continuous probability distribution or discrete. Right? Remember, the discrete variables are the ones that are counted, are whole number values. When we form a probability distribution, this is what happens. We get the values of these random variables, and we also have the probabilities associated with them. Like for example, so you're running a business, right? Everybody with me? I run a business. And you say, all right, you know what? You normally sell a certain number of products, or a specific product that you have. So you're selling water. And sometimes you sell 100 bottles of water, sometimes you sell 200, sometimes you sell 500, sometimes you sell 5,000. Those are the values that your sales or your sales figures. You can have different sales figures on a daily basis. Right? Now, the probability that you sell 0 or 10 or 100 or 1,000, the probability associated with those values of random variables, if you have both of those together, you probably have what we call a probability distribution. Right? I look probably like you still get America. Right? Let's get into it. We say random because usually the values of these variables, we pull them in no particular order. What does random mean?
No thought. That's a no
No
thought.
particular order. So if somebody says, you know what, I'm going to just randomly select a value, what are they saying? There's no predetermined structure. There's no specific number in mind. I'm just going to pull one without having any structure in mind. Right? So that's the concept of randomness. So in probability, we normally talk about random selection. Remember we talked about random sampling? Remember that? That was in the mid-semester exam. Yeah. So random sampling is the same concept that we're utilizing within probability. Random selection. Remember, you have this already, so you don't have to write off of it. I'm going to tell you what you write. Alright? So, as we said, we can have discrete and continuous random variables. Right? Random variables. We normally have, there are normally several possible outcomes. Right? And the different outcomes are going to take on different values. Right? We went through this already. This is testing to know what's the difference between discrete and continuous. Remember, discrete variables are the ones that are counted. The continuous variables are the ones that are measured, right? And take on discrete variables only take on whole number values. The first one, the number of misspelled words that spelling bee competition.
Discrete.
Discrete?
Yeah.
What about the amount of water going to the motor?
Continuous.
Continuous. How late you work for class?
Continuous.
The number of bacteria in the water sample?
Discrete.
Why discrete?
Because one bacteria like one person, so
Exactly. Even though you might have millions,
yeah.
it's you can't have 1.5 bacteria. Alright? What about the amount of carbon monoxide produced?
Discrete.
The amount of carbon monoxide?
Liter.
Count it or measure?
Measure it, yeah.
Measure.
Yeah.
So that makes it
Continuous.
continuous. What about your weight?
Continuous.
Ladies, your weight.
Ladies.
Yeah, your weight.
Continuous.
And then always some ladies. Alright. Why is weight continuous? Because it's usually measured. So that is measured, right? What about the number of ladies that it goes to? Discrete. Number of ladies. Alright. The amount of time waiting in the store. Amount of time. Time, you can express time in decimals. Notice the difference between continuous and discrete. Anytime you're talking about a discrete variable, it's something that is counted and usually is referred to as the number of. Anything that you count, you normally say the number of. Anything that you measure, it's always the amount of. I'm the math teacher and I should be teaching the English. So anytime, anything that you measure, like for example, the amount of water, you don't say the number of water in a glass. The amount of water in a glass, right? So usually anything that you can measure is the amount of. And anything that you count is the number of persons, the number of markers, the number of bottles, but the amount of water in a container. Anything that you measure is usually the amount of. Even time, the amount of time it takes. You don't say the number of time. You see what I'm saying? So any one of them that is the number of is usually discrete. Here is an example of a probability distribution that we have to look at. Alright, this is an example of a probability distribution. Like for example, you throw that and count the number that fall on top. Well, add up the number that fall on top. You have 1 out of 36 possibilities of getting a 2. Because there's only one possibility of getting a 1 and a 1. You have to get a 1 on one dice and a 1 on the other. Right? There are 2 possibilities of adding and getting a 3. You could get a 1 and 2 or a 2 and a 1. 2 possibilities out of the 36 possible outcomes. For getting a sum of 12, you only have one possibility. 1 out of the 36 possible outcomes. Right? So, this, when we put it together like this, it forms a probability distribution because we have all of the possible values of the random variables. You can add 2, 3 up to 12. And then these are the different possibilities. And you add them up, you get 1. Any probability distribution, when you add all of the probabilities, you get 1. So the sum of the probabilities of any distribution, probability distribution, is equal to 1. That is something that you have to remember. Alright, so let me show you a couple of things. We're gonna, well, these are a summary of some of the things that we talked about already. The list, I'll put this over there. A probability distribution. It gives all of the values of the random variable, right? Alright, let me show you something. So we're using x to represent the random variable. We use the capital uppercase letter X to represent the definition of the random variable, defining what the random variable is. But if we use x, the number, the value, we use the lowercase x to represent it. So we use lowercase to represent the value of the random variable. Alright? And so for example, we use q to represent the random variable. We're going to use the lowercase q to represent the values.
Okay.
But the most popular one is x, right? Sometimes we use y. But the most popular one is x. This is a shortcut we have writing the probabilities associated with a particular value. Let me show you how we write it. We write it like we write it up here. So, this is how we write it. The probability that my random variable x takes on a particular value. That's how we write probabilities. This one is a shortcut we have writing it. Yeah? Okay. Let's get into it a little bit more. Now, each event or each outcome is mutually exclusive. It's like, for example, throwing a dice. You can get a 1 or a 1. When you throw a dice, you can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. But if you throw one dice, you can get a 1 and a 2. Or you can get a 1 and a 2. So that means getting a 1 and a 2 is impossible. That means they're mutually exclusive, right? That's the concept of mutually exclusive in this case. You can't get a 1 and a 2. Alright? Okay. And that means there is no overlap. Collectively exhaustive means if you present the probability distribution, you present all of the possible values of the random variable. Like when you throw that, you can get a 1, 2, 3, 4, 5, and 6. You put down all of those possibilities and then give them the probabilities associated with them. We mentioned earlier that any probability that you write, it has to be between 0 and 1. Right? You remember that? It can't be a negative value, and it can't be above 1. It has to be between 0 and 1. Alright, you know what? Let me start giving you some work. We mentioned this up top here already. And when you add up all of the probabilities, you get 1. Alright, so let's look at this example. This is actually reminding you of this particular cumulative function. This is what this is saying. F of x is my cumulative probability, right? It's actually saying the probability that my random variable x is less than or equal to a particular value. Like for example, f of 3. Let's write in f of 3. F of 3 is equal to the probability that x is less than or equal to 3. Let's add this. The probability that x is less than or equal to 3 is equal to the probability that x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that x is equal to 3. Notice, we capture all of the values of the random variables from 0 up to 3. And we're going to present the probabilities for them and add them. Let's do it. Are you ready? The probability that x is 0 in this example, what is it? 0.1. Probability that x is 1. These are my probabilities. 0.2. Probability that x is 2. And 3? 0.2. Add them up for me. 0.8. That means f of 3 is supposed to be 0.8. So if we look over here in my f column, f of 3 should be 0.8. Are you seeing it? Yes, that's a cumulative.
Sir, go over that again. Over that again, yeah.
Alright, so f of 3, if the chance that x is less than or equal to 3, I mean the probability that x is 0, 1, 2, and 3.
Yeah.
Less than or equal to 3. All of the whole numbers from 0 up to 3. Right? So, if I want to find f of 3, I would have to add up all of the values, all of the probabilities from 0 to 3. So when you add these up, we're going to get 0.8 as we see here. Right?
Okay.
Which is actually f of 3, which is represented right here.
Right.
0.8. So, I could ask you, what is f of 2? F of 2 is 0.6. I mean, when I add up all of this, I should get 0.6. Right? How do we create the F column? The cumulative distribution. What we do, we start with the first probability, 0.1. And then add 0.2 to 0.1 we get.
Sure.
Then add 0.3. Then add 0.2. Then add 0.1. Then add 0.1. And that's my cumulative. That's good? Alright. Then take this off. Alright, so let's take a look at this very distribution, but we're going to be calculating some stuff. Don't worry, I'm going to get back to you. There's my f of 2. Yeah, I'm going to come back to you. Alright, so this is explaining some other stuff. We're gonna actually calculate what we call the mean. The mean, remember how we're at the mean? Another term for the mean is the expected value. In this case, okay. So the expected value, like for example, we could give you a set of stuff and say, find the expected value of the random variable. Expected value, we're saying find the mean. Alright, pull up the calculator. We're going to do some calculation. So, for this example, we went ahead and found the mean. We're going to go back to our original example. And we're going to find the mean for this one. Let's use this distribution and find the mean. Let's check if it really is a probability distribution. If it's a probability distribution, when we add up these, we should get 1, right? Add them up and then tell me if we get 1. We're going to eliminate the cumulative distribution because we don't need it to find it. So we're going to take this off. We don't need it to find the mean. Right? Okay, so I want you to come with me now. Let's do some calculation. We're going to find the mean. So the mean.
Yes, sir, I got 1.
You got 1? Alright, sounds good. That means it's a probability distribution. And we mentioned that the mean is the same thing as the expected value of that, right? The question is, how do I find my expected value? It's equal to the sum of each x value multiplied by the corresponding probability. Everybody heard that? Alright, so we're going to write it. Alright, jot down this distribution. This is the first 2 columns. So the first 2 columns